Hi all, a very good evening to all of you. So welcome to another lecture. In this one, I'm going to talk about the strategy for organic chemistry, right? So I've taken questions from June 2017 onwards because the pattern of the exam was slightly changed back then. So from June 2017 onwards till December 2019, we have 6 examinations. So we are going to evaluate what kind of questions or what kind of pattern can you see in those 6 examinations, and this would be particularly useful for someone who wants to prepare a bit of organic chemistry, or at least wants to score 30 to 40 marks from the organic chemistry section, right? So I've discussed about the name reactions, the reagents, which are most commonly asked, the part B, the part C as well, like what kind of questions are there in part C, how you can prepare for part C, that is a 4 marker questions, and how you can prepare for part B. All right. And for a more detailed analysis from June 2017 to December 2019, where I will take and analyze each and every question, I'm conducting a free live class on Unacademy as well, for which you'll find the link down in the description box. It's completely free. It's a live class. It's on 11 June at 8:30 p.m. So don't forget to join in for that particular class. The link, like I said, is available down in the description box. All right. So now let's begin with the strategy. So before we come on to the name reactions and the reagents, let's talk about the part B over here. So when you talk about the part B, just give me 1 second, right? So when we talk about the part B, the most important part in part B is the reagents. Okay, always you will find that there will be one particular question that will be asked from your reagents. I have circled it in green because it generally the questions are quite easy. So you will see reagents like NBS being asked, MnO2. Okay, it's a chemoselective oxidizing reagent. Then like I said, in bromosuccinamide, sometimes it will go by the radical mechanism, sometimes it will act as electrophilic bromine. So these kind of simple reagents are quite recently in December 2019 there was a question based on hydrogenation, metal hydrogenation in the presence of nickel, right? So very simple questions come from reagents. Very typical reagents are asked, not the difficult ones. Sometimes sodium cyanoborohydride, it's also a chemoselective reducing reagent. So those kind of simple reagents are asked for 2 marks, which you can very well prepare. All right, I'll give you a list of the reagents as well. Then pericyclic is something you'll find another 2 marker in part B. Okay, pericyclic reactions, it could be from anything. Generally what I've observed is the questions are from Diels-Alder. Particularly there are so many questions that have been asked on the reactivity of different dienes and dienophiles in a Diels-Alder reaction, right? In particular the dienes, so how the dienes react, which diene is more reactive, which one will undergo Diels-Alder reaction faster. Sometimes there will be a simple question on electrocyclic ring opening or ring closing as well. All right, so these kind of questions are there. Most recently in the December 2019 exam, it was related to delta H and delta S of a Diels-Alder reaction, that what will be the value of delta H and what will be the value of delta S for a Diels-Alder reaction. So these are the kind of reactions that are asked. Sometimes there might also be a question on the reactivity, like on the homo-lumo concept of the pericyclic reactions, right? Then there'll always be, most of the times there will be a question on the number of signals in the 13C NMR spectra. That is a very common reaction that you see in the CSIR examination, right? Then we have questions based on IR stretching frequency. Mostly it is asked from your carbonyl stretching frequency. Okay. Then we have mass spectra. In mass spectra, simply questions come from either the abundance or the McLafty rearrangement or the ortho effect. These are the 3 topics from which the questions come from the mass spectrometry for 2 marks. Then we have stereochemistry. In stereochemistry, there can be a wide variety of questions, but the questions, like I said again, are very simple. The questions mostly are based either on the conformations of cyclohexane. Sometimes if conformations of cyclohexane are not given, then decaline system will be given. Okay, decaline system, I'll write down over here, I've not mentioned, decaline system will be given, right? Then we have questions on helical chirality. In December 2019, there's a question on helical chirality on cyclophane kind of ring systems, right, where there's a pilot atom present. Then alkylidenes. Okay, you can search these topics. Then enantiomeric excess, topicity, whether it's distereotopic, homotopic, enantiotopic protons. Okay, so those kind of questions are all based on the symmetry. So these are some of the questions that are asked. Maybe the RNS nomenclature of spiranes, maybe the RNS nomenclature, simply a simple RNS nomenclature might be asked to you. So these are very simple questions from stereochemistry. Then we have questions, mostly there will be 2 questions from stereochemistry, okay, in the 2 markers. Then we have questions from general organic chemistry. Now general organic chemistry can be very vast. but one typical question that has been asked most commonly is based on solvolysis. Okay, so please do this topic properly. It's basically you can say based on your SN1 reaction, and similarly the neighboring group participation based questions. Okay, NGP questions and solvolysis, these are very common 2 markers. Then we have stability of carbocations or stability of carbon ions, acidity basicity topic, right? Elimination reactions, by which mechanism is it going, whether it is going by E1CB, E1 mechanism, E2 mechanism. Then similarly for nucleophilic substitution, whether it is going by SN1 mechanism or the reaction is going by SN2 mechanism. So these are some of the most easy questions that are asked from part B. Coming on to part C, coming on to part B, you can say a bit difficult questions. That's why I've said I've like highlighted them in orange, right? So one question would definitely be on natural products or pharmaceutical chemistry. Now I don't recommend you to do this topic. If you have a good general knowledge, maybe you might be able to answer questions from a pharmaceutical chemistry, right? And similarly for natural products, if you really want to do natural products, you can do maybe terpenes. Okay, or how many units are basically something related to terpenes, and how each unit is made of how many isoprene units. Like for example, if a molecule is given, how many isoprene units are there. So those kind of questions, if you want, you can do, but I would not recommend you devoting time to natural products, because the questions are very random and the topic is very vast. All right. Then we have questions from rearrangement reactions. Now when we talk about rearrangement reactions, again it's a tricky business. Okay, you have to do all name reactions which are based on rearrangements, right? All kinds of rearrangements, right? I will highlight what kind of rearrangements are more plausible to come, but you have to do all kind of rearrangement reactions, and these questions can be a bit tricky, right? So there will be a question, there is always a question from rearrangement reactions, right? Sometimes in one of the papers there was a question based on Friedel-Crafts reaction of beta naphthol. Okay, they had asked that what will be the most nucleophilic position in the beta naphthol. Okay, so those kind of questions, but mostly it will be based on rearrangements, right? Either ring expansion will be taking place or ring contraction will be taking place, some kind of that kind of reaction, right? Then there is always a question based on reactivity of heterocyclic compounds, and mostly I have seen that the question is based on pyridine. Okay, a lot of questions. In fact, in December 2019 there was no question on the reactivity of pyridine, so they asked the question on the 13th NMR of pyridine. Okay, so pyridine is a heterocyclic molecule which is most widely asked in the CSIR examination. You would see a lot of questions, particularly from June 2017 onwards, based on the pyridine scaffold, be it in 2 markers or 4 markers. So this is a very important scaffold in heterocyclics, along with pyrrole, thiophene, furan also. But pyridines are the ones which are the most, which are being asked, or which has a more chance of being asked as compared to the other heterocyclics, right? And then we need to know about the various protecting and deprotecting groups, like what are the conditions in which they get deprotected, what are the conditions to protect a particular group, how we can chemoselectively protect a particular group, like acetyl protection, BOC protection, carbox CBZ protection, right? Then we have like your what else, there are other protecting groups as well, right? Acetyl, BOC, CBZ, OBN, benzyl protection, right? So how we deprotect it, like benzyl can be deprotected in the presence of hydrogenation in palladium and carbon. Then your your FMOC group is also there. Then BOC can be deprotected in acidic conditions. So you should be aware of what are the conditions in which these kind of groups get deprotected. So these are some of the 2 markers that are asked from the CSIR point of view. So these, the green ones, are the easy ones. You can, if your basics are good, and this is nothing, this is not advanced topics, these are very very basic topics, right? So if you can do this, at least you will be able to score 12 to 14 marks. In total there are 13 questions being asked from part B. Okay, there are 13 questions asked from part B, so I'm sure that you can easily do at least 6 questions from part B, and you can at least score 12 marks from part B if you do these topics well. All right. And then if you rearrangement questions are quite tricky, so only if you're confident about that you should attempt them. And similarly the questions that are based on reactivity of heterocyclics are also quite conceptual, right? But again, your protection deprotection, if you're aware of this, that on what, in what conditions these groups get deprotected, then you can surely score marks over here as well. And this would always be something which will be which you'll only get to know in the examination, that whether you know the answer to that or not, right? Now let's talk about your part C. So in part C, the most important part to focus, or the part which carries the most amount of, like, very high weightage, and is quite easy to understand as well, is pericyclic. And particularly I would like to highlight over here for to like highlight over here 2,3 sigmatropic reactions. They are so commonly asked in CSIR examination. They would not be a direct question, but there will be 10 in one of the examinations. There were 10 indirect questions based on your 2-3 sigmatropic reactions. I think around 8 or 10 reactions. So 2-3 sigmatropic reactions are very, very common when it comes to CSR examination, right? In general also, when you see research based papers, 2-3 sigmatropic reactions are very common. They are very, very commonly asked, right? So we have electrocyclic reactions that you need to do 4 plus 2 cycloadditions and 2 plus 2 cycloadditions. Very, very important. Okay, this is something that you need to do. Pericyclic you really need to focus on. Again, I'm saying on 4 plus 2 and 2 plus 2 you'll see direct questions also, but 2-3 sigmatropic direct questions would not be there, but it will be utilized in a lot of questions in organic chemistry, right? Then simple sigmatropic like 3-3 sigmatropic, Claisen reaction as a co-prearrangement, right? So these kind of topics, these are the things you need to focus on in pericyclic. Photochemistry is not very widely asked. Okay, recently you would see from June 2017 onwards, not a lot of weightage is given to photochemistry. So if you want, I'm sorry for the wrong spelling, so you can do Norris type reaction, Norris type 1 and 2 if you want, but I would not recommend you photochemistry, to be honest. Okay, so I won't recommend you doing this topic, right? Then the most important one is oleifinations. You need to do all kinds of oleifinations that you can find in name reaction books. So either you can follow CSACO. Okay, there's a book called CSACO for name reactions, or you can follow G. Okay, so there any name reaction book that you like you find, particularly CSACO and G have covered it extensively. There's one more book called Hassner. Okay, HASSNER. So these books are good for name reactions, and whatever olefination reactions are there, you have to do all olefination reactions. Okay, this is one question that will always be asked in the CSR examination: olefination reactions, right? Be it Takai olefination, Peterson olefination, then we have Julia olefination, Wittig reaction, Horner-Wadsworth modification, whatever different kinds of olefination reactions are there, you need to do all of them, right? Then we have Sharpless epoxidation. This is also one topic which is more or less asked in every examination. Then we have Corey-Chaykovsky reaction. Ring opening of epoxides, again a very, very important part. Okay, again, see, direct question would not be there from ring opening of epoxides. It will be utilized in the question, and this is where the confusion comes, because ring opening of epoxides is more or less regioselective. Okay, in acidic conditions it will open from the different side, from the more substituted side. In basic conditions it will open from the less substituted side. So the regioselectivity comes over here, and that's why the ring opening of epoxides is very widely asked in the examination. So this is one topic you really need to master before you sit for the examination, right? Then we have questions based on enolate chemistry. So in Claydon, I think there are 3 or 4 chapters based on enolate chemistry. You need to do all of them. In particular, where it leads to a different product, a distereomeric product. Okay, so enolate chemistry is very important. Then there will be a usual question on structural elucidation from NMR spectroscopy for 4 marks, and then maybe you might be given the IR data also along with that, and there might be a question from mass also. Sometimes mass is incorporated in the structural elucidation question, or sometimes there's a different question asked from mass spectrometry, right? So these are some of the topics that you can really do. Similarly, like I discussed about olefination, the rearrangement reactions also, you need to do all the different kinds of rearrangement reactions that are given in these books, right? Scatter ball rearrangement, Favorsky reaction, dienone-phenol rearrangement, I mean, there are so many reactions, benzylic acid, right? So whatever different kinds of reactions that you get, right? Pinacol rearrangement, basics ones, and also the advanced rearrangement reactions, right? You need to do all different kinds of rearrangement reactions, right? Then coming on to coupling reactions. In coupling reactions, particularly you need to focus on Heck. This is most commonly asked. Okay, Heck reactions, because over here also regioselectivity comes into the picture. Sometimes the stereoselectivity also comes into the picture. So Heck reactions are very important. Coupling reactions in general are quite simple, but in Heck, basically your stereochemistry and your sometimes your regioselectivity and your stereoselectivity comes into the picture. So that is why it is most commonly asked, right? Then this time I'm expecting more questions from benzenes. So in the December 2019 examination, you saw two questions from carbenes. There were two questions from carbenes, right? So this time I'm expecting that at least there will be one question from benzene mechanism, right? So you need to do that as well. And then similarly over here also, a direct question would not be there, but it will be utilized in some question, the protection and the protecting and deprotecting groups. Okay, the conditions required for protection and deprotection. Now the important part you need to understand over here is that in most of these topics, or in organic chemistry in general, there would not be a direct question based on one singular topic. There will be two topics always combined together in organic chemistry, especially for 4 marks. You will not find a question that will be directly asked to you for 4 marks, okay, on a particular name reaction or on a particular topic. It will always be in combination. For example, if I talk about sharpless epoxidation, first your olefination might take place. Let's say your Peterson olefination might take place, and in the next step you have been given sharpless epoxidation, right? So these two will be combined together, olefination reaction and sharpless epoxidation. Or it might be given first, alkene will be given to you, sharpless epoxidation will happen, and then your nucleophile will come and it will lead to ring opening of the epoxide. So you need to know both these concepts in order to master or try to predict the correct answer for a 4 marker. So that is a very important aspect that you need to understand, that unlike physical chemistry where you have a direct question based on the concept, so either you know the concept or you don't know the concept. Over here, if you know the concept as well, if you know one concept, it would not be enough. You need to know both the concepts in order to solve the questions, and that's why the organic chemistry becomes difficult for the CSIR examination, because most of the times it happens you know one part, so you are able to eliminate two options, but then you get stuck in two options, or if you try to take a guess, most of the times you take a wrong guess, right? So that is the reason behind that you need to know both the concepts. Now coming on to the name reactions that are important. So like I have listed down some of the reactions that have been asked previously, right? Like I said, all rearrangement reactions, all olefination reactions are very important. Apart from that, we have your Michael reaction, Manich reaction, Simmons-Smith reaction, Corey-Chaykovsky reaction, sharpless epoxidation, dihydroxylation, all kinds of dihydroxylation. There's one Woodward's dihydroxylation as well, which I've mentioned over here, right? Then in presence of dilute KMnO4, osmium tetraoxide also leads to olefination. Then leads to dihydroxylation. Then all olefination reactions, all rearrangement reactions, Shapiro reaction, Wharton reaction, Riemer-Tiemann reaction, Arbuzov, McMurray coupling. Then rearrangements I have particularly listed which have been asked before, like Pomeroy rearrangement, Pine rearrangement. Similarly, olefination that have been asked before are Julia olefination, Wittig reaction, Peterson olefination is very important. Then your Stork-enamine reaction, Alder-Ene reaction, Bergman cyclization. Then we have Wilsmer-Huck. Barton reaction is quite important. Clason and Azocope is very important. Heck, I already mentioned, is quite useful. Metathesis is something that if you want you could do. Kulenko, which is also a part of olefination. So that's why I'm saying olefination, and most recently Takai olefination was also asked, right? So Takai olefination, Kulenko olefination, these kind of reactions you will only know once you read these books, okay, name reaction books. That's why I'm saying olefinations, they can ask you any different kind of olefination. So it's better that you do all olefination reactions and all rearrangement reactions, because they would definitely come for 4 marks in the CSIR examination, no doubt about that. Okay, olefination and your rearrangement reactions, they will always be asked in your CSIR examination, right? So this is important. In rearrangement, like I mentioned, forgot to mention, Beckman also is there. So basically all different kinds of rearrangements, all different kinds. How so many number of rearrangements you can do, it's better for you. All right. Coming on to the reagents. So if I talk about reagents, the most commonly that have been asked, I've highlighted over here pyridine N oxide and sodium cyanoborohydride. These are very, very commonly asked. Particularly pyridine N oxide, you will almost see in every examination. Okay, so you need to know the reactivity of pyridine N oxides, how they react, and sodium cyanoborohydride. Along with that, you would see a question definitely from your Birch reduction part, that's lithium and liquid ammonia. Then ozonolysis, O3, very frequently asked. Okay, ozonolysis. Then NBS is a very popular reagent. MCPB is a very popular reagent. Okay, here also in MCPB why are these popular reagents? Because they lead to chemoselective reactions, okay, or they might to lead to regioselective reactions, right? So for example, if I talk about alkenes, so MCPBA selectively will act on electron rich alkenes, right? Similarly, why Siemens-Smith reaction is asked? Because in Siemens-Smith reaction, it will selectively act on electron rich alkenes, like it will lead to cyclopropionation on electron rich alkenes, because carbenes are electron deficient. Similarly, MCPBA is also, you can say, like it acts via electron deficient mechanism. Whereas if I talk about hydrogen peroxide, I might have mentioned it, H2O2 NaOH, this also leads to epoxidation. MCPBA also leads to epoxidation, but MCPBA acts on electron rich alkenes, and hydrogen peroxide and sodium hydroxide acts on electron deficient alkenes, right? So these are the concepts the examiners want to test. That's why they give you these reagents, because there is some kind of selectivity involved. Similarly, if I talk about your Luce reagent, so again selectivity comes into the picture over here. Fetison's reagent, okay, it's oxidizing reagent, okay, and it particularly selectively oxidizes secondary alcohols, right? So these are the kind of questions you might be asked, or those are the reagents that might be given to you, which lead to selective reactions, either chemoselective reactions or regioselective reactions, okay. Then we have TBAF, that is tertiary butyl ammonium fluoride. It is a deprotecting group, okay, it will lead to deprotection of your silicon, right, silicon protecting groups. Then we have MnO2, it will selectively lead to your oxidation of benzylic alcohols or allylic alcohols, right? Then we have selectride, K and L selectride, you can study about them. Then we have your hydrazines, okay, tosyl hydrazines are most commonly asked. Hydrogenation reactions, be it palladium on carbon, or otherwise any kind of metal, it could be Wilkinson's catalyst, so those kinds of hydrogenation reactions. Then reducing reactions in the form of lithium aluminum hydride, sodium borohydride, sodium cyanoborohydride, uh, lithium borohydride, okay. Then Lindlar's catalyst, okay, it is also a part of hydrogenation only, but it specifically leads to cis alkenes. So this is where it is important, because it selectively leads to cis alkenes, whereas if you do burst reduction of alkynes, it will lead to trans alkenes. So these are the kind of questions they would be asking you, right? Then samarium iodide, selenium dioxide, right? Then we have LDA. Basically, whenever LDA is given to you, in general, you would see the question is based on the enolate chemistry. Okay, so LDA as such is not very important reagent, but it is a very important to generate a enolate, and that is where the trick will come. Once the enolate is generated, you need to know about the enolate, right? What kind of enolate is generated, whether it's a E enolate or a Z enolate, and that's how you are going to do the question, right? Then NBS I've already mentioned, sorry for mentioning it again. Osmium tetraoxide I've discussed, KMNO4 I've discussed, right? So these are some of the reagents that might be useful, or that are most commonly asked, I would say, in the last 6 examinations of CSIR, right? So I hope that this session was a bit helpful to you, especially if you're beginning with organic chemistry, and if you want to have a more detailed overview, and if you have particular doubts regarding what you need to study and what you don't need to study, then I am having a 2-hour marathon class, live class, which is free of cost, which is available on Unacademy. Okay, it's a live class. I would be starting, like I said, at 8:30 p.m. on 11th of June, right? So you can join me over there. The link to the class is available down in the description box. All right. So anyway, I hope you enjoyed this class. If you did, please like this video, and if you haven't subscribed to this channel, I would request you to please subscribe to the channel. It motivates me a lot to make more videos for all of you, and make it more regularly. That is more important, right? So thank you, and see you on 11th of June at 8:30 p.m. on Unacademy.
Hey guys, so I'm a verified educator on Unacademy, and along with that I'm also available on the Unacademy Plus platform, where I'm taking live classes along with other educators. So in case you're interested in attending the live classes, you can subscribe to the Unacademy Plus platform using my referral code, that is SETHI, and that will give you 10% discount. Alright, and in case you're not interested in attending the live classes, you can watch the free courses that are available on the Unacademy. For that, all you need to do is go to the Unacademy website or download the Unacademy Learning app and search my name over there, that is ACT. Once you do that, you will get the access to all the free courses that are available on the Unacademy platform.